Okay, so now we've made it to the first section of learning about unit testing. And in this section, we're going to kind of go over a few concepts and talk about a few things to help you get an understanding of what you are about to embark on and learn. So, if you're new to this channel and you would like to follow along with the curriculum, the link is in the description. It's free. You don't have to register for anything. So, let's get into the curriculum. Why test your code? Checking your code is part of the development process. Developers rarely write code without verifying it. You are used to debugging programs as you write them. In fact, we devoted an entire chapter to debugging earlier in the course. Your development process probably looks something like this. Write code, run program, notice error and investigate. Repeat these steps until there are no more errors. But there's a better way to test your code, using automated tests. Automated tests actively test your code and help you to remove the burden of manual testing. There are many types of automated tests. This chapter focuses on unit testing, which tests the smallest components or units of code. There are typically individual functions, or these are typically individual functions. Before we dive into how of unit testing, let's discuss the why. Know your code really works. Manual testing can eventually lead you to a complete error-free program. Unit testing provides a better alternative. This might sound familiar. You write a program and manually test it, thinking it is complete. You turn it in only to find that it has a bug or use case that you didn't consider. This is possible right here. This is why it's important to learn how to ask questions. Key here, use case. This a lot of the times is where a lot of your issues are going to come from, because when you're writing your functions, you want to kind of think through the whole process. This is why I'm constantly talking about you must know what the result is before you write the code. And one of those things that we have to think about are use cases, different types of use cases. So the function may be simple and do one thing, but yet when you write the unit test, and you're about to find out that it seems like the unit test has more, you're writing more code just to make it, to test it to make sure it's working properly. And that's because you're testing for different use cases. Now, you may be familiar with this a little bit when we gave you your first assignment and you had to pass certain tests. You had a whole bunch of tests that you had to pass before you got the green light that everything was ready to roll. But it doesn't mean your program was working properly. It's just that you wrote good unit tests. You passed all the unit tests. So it's twofold here. Not just only writing the test just to pass a certain use case, but you want to make sure the functionality is working correctly. We're going to talk a little bit more about this. So the unit testing process helps avoid this by starting with a list of specific, clearly stated behaviors that the program should satisfy. The behaviors are then converted into automated tests that demonstrate program behavior and provide a framework for writing code that really works. Find regressions. What about this situation? You write feature number 1 for a program. You then move on to feature number 2. After finishing feature number 2, you realize that your changes broke feature 1. This is frustrating, right? Especially with larger programs. Adding new features often causes unexpected problems in other parts of the code, potentially breaking the entire program. The introduction of such a bug is known as a regression, and we're going to talk about regression testing. If you have a collection of tests that can run quickly and consistently, you will know right away when a regression appears in your program. This allows you to identify and fix it more quickly. Test as documentation. One of the most powerful aspects of unit testing is that it allows us to clearly define program expectations. What do we mean by this? Well, up until this point, you've been writing comments. You can write comments in your code. That's okay when it's not a really big project, just getting started. You're learning how to write programs. To remind yourself what you are actually doing. So that's what writing comments are good for, to kind of help you remember what your thought pattern was when you were writing certain functions. But that is not a good practice, because what happens if someone else takes your code and begins to update it and change it? Most likely they're not going to update the comments. And so as the code goes forward, those comments are outdated. This is what writing good tests are for. It's for documenting your code. This is why we want to write unit tests, because this keeps your code up to date. It keeps what it's supposed to be doing up to date. And we'll give you more of an understanding of what I mean later. A good collection of unit tests can function as a set of statements about how the program should behave. You and others can read the test and quickly get an idea of the specifics of program behavior. Your coworker gives you a function that validates phone numbers, but doesn't provide much detail. Does it handle country codes? Does it require an area code? Does it allow parentheses around area codes? These details will be easily understood if the function had a collection of unit tests that describes its behavior. This is important to understand, because this is one of the things when you're writing code you want to get an understanding about. To you, this is not an issue. You're used to having an area code and writing a 7-digit phone number. But when you're writing code, you got to take in consideration, how do we want to format that? Are we going to use parentheses? Are we going to use dashes? Are we going to do forward slashes? Or are we just going to have it all run together? Do I need to write regex to get rid of the dashes and just make it one continuous string? Is it going to be a number? These are the things that you need to ask yourself when you're writing your code. Code with a good descriptive set of unit tests is sometimes called self-documenting code. Remembering what your code does and why you structured it a certain way is easy for small programs. We were talking about those comments. However, as the number of your projects increase and their size grow, the need for documentation becomes critical. Documentation can be in the form of code comments or external text documents. These can be helpful, but have one major drawback, which is that they can get out of date very quickly. This is what I was talking about earlier. You write the comment, you write the instructions, you write the documentation, but if nobody updates it, it gets out of date very quickly. So outdated, incorrect documentation is very frustrating for a user. Properly designed unit tests are runnable documentation for your project, because unit tests are runnable code that declares and verifies features. They can never get out of sync with the updated code. If a feature is added or removed, the test must be updated in order to make them pass. Let's go ahead and write the first unit test. Okay, and we're going to do that in the next section. We're going to go into the documentation, go into our VS Code, and we're going to play around with the code in the next section. But this last paragraph is so important to understand what we're saying, is that we need the test to make sure that the code is in sync. So when we teach you how to write the test, you're going to document what each one of those tests are doing and what it's checking for. That's why it's so important for you to understand how functions work. And this is just another way to learn and exercise your thought pattern on writing functions by writing good tests. Okay, so we made it to the end of this section. Remember, the more you do, the more you improve. See you in the next section.